Hello, everyone, and welcome to our webinar. Our topic today is titled, Code-Compliant Portal Frames Built Right. My name is Karen Beebe, and I will serve as moderator for the session. Our speaker, Kathy Scarrence, and I both work for APA, the Engineered Wood Association. APA is a nonprofit trade association representing manufacturers of a variety of common structural engineered wood products. In addition to quality verification and product testing, APA conducts research to improve engineered wood construction systems and educates users and specifiers on products' proper use and potential applications. Before we start today's webinar, I need to cover some housekeeping details. Kathy's presentation will last about 30 minutes. To ensure that everyone can hear it clearly, we've muted all participants. We do encourage you to submit questions by typing them into the questions pane on the control panel on your screen. We should have time to answer most questions, but if we run short, we'll be sure to post a Q&A summary on our website, along with a recorded version of today's program. We should have those posted in a week or so. Our presenter today is Kathy Scarrence, Engineered Wood Specialist for APA based in Texas. In that role, Kathy works with designers, builders, building officials on the various engineered wood products that are used in building today and consults on engineered wood use in construction applications. Prior to joining APA, Kathy worked as a structural engineer for 6 years, designing a variety of building types in wood, concrete, steel, and masonry. Kathy also worked for general contractors in the non-residential construction industry for 18 years. In this field, she performed primarily quality management roles, both as an inspector in the field and as the manager of a quality program. For those of you just joining us, welcome to APA's webinar on the topic of portal frame solutions for wood frame structures. I will now turn the microphone over to our speaker, Kathy Scarrence.
Thank you, Karen. In today's webinar, I'll be discussing the value and importance that portal frames provide to meeting the wall bracing provisions of the International Residential Code. We will talk briefly about lateral load paths and discuss the role that portal frames provide in resisting these loads. Then we'll review proper installation of portal frames and the portal frame options found in the International Residential Code. Finally, we will look at portal frame installation errors that are commonly observed by APA. Let's get started with understanding load paths. Section R301.1 of the IRC states that structures shall result in a system that provides a complete load path that transfers loads from their point of origin to the foundation. Dwellings constructed as prescribed by the IRC are considered to comply with the requirements of this section. The purpose of the load path is to take the load from where it is applied to the structure and get it down to the foundation. There are two kinds of load paths that need to be complete for a structure to be properly designed. They're both required in the IBC and IRC. Vertical load path relates to live and dead gravity loads, such as structure dead loads, occupancy loads, or snow loads. Lateral or horizontal load path relates to wind or seismic loads. Let's take a look at gravity loads first, because they are easier to understand. The load path is simply the path that the load takes as it passes through the structure and its components and connections on its way to the ground. In the vertical load path, the members above bear on members below, thereby transferring loads from above all the way down to the foundation. The vertical load path is fairly intuitive. Everyone understands gravity. The lateral load path is not as intuitive. Lateral loads are forces that act on the side of a building, parallel to the ground, such as wind or seismic. Walls must be strong enough to resist the wind forces that push against the building. During a wind event, the wind pushes against one end wall while pulling on the wall on the opposite side. The walls on the other two sides of the structure, the bracing walls, must hold the structure from moving. The 2018 IRC applies to residential structures located in areas where the ultimate design wind speed is less than 140 miles per hour. In high wind regions, wind design of the building is required. Wind speed maps are located in Chapter 3 of the IRC. Seismic forces are generated by ground motions during an earthquake. The ground motion causes the structure's mass to accelerate back and forth and up and down. This acceleration causes forces to develop within the structure in the locations where the structure's mass is the largest. Essentially, the seismic ground motion measured as acceleration acts on the foundation, while inertia controlled by attempts to keep the structure from moving with the foundation, causing shear forces on the walls. The IRC publishes earthquake maps of the United States that breaks regions of the country into seismic design categories. The earthquake maps are also located in Chapter 3 of the IRC. These seismic design categories range from A to E, with A being the lowest seismic intensity. The provisions of the IRC are applicable for structures in seismic design categories A through D2. Structures located in seismic design category E cannot be designed using the IRC. The lateral load path in a structure transfers these lateral forces to the ground. Let's take a look at the load path for a lateral load. The forces begin at the wall, where they are transferred through the studs into the roof and floors of the structure. Once the lateral loads have been transferred to the roof and floors of the structure, the roof and floor systems move the load over to the side walls, where it moves into the bracing and the walls of the story below. At this point, the bracing and the sidewall on the second floor carries the lateral load from the roof down to the second floor. The bracing and the sidewall on the first floor carries the lateral load from the second floor down to the foundation. If the forces don't reach the foundation, that means there has been a failure. This would be evident by structural damage at the location in the structure where the load path failed. The connections throughout the structure are very important. The load path depends on these connections to transfer the forces through the building to the foundation. Chapter 6 in the IRC has a table, Table R602.3, that gives the number and size of fasteners for these connections. Now that you have a better understanding of load paths, let's take a look at why wall bracing and portal frames are so important to the structural integrity of a house. If a wall only has a few small openings, bracing it is easy. But large openings, such as garage door openings, can complicate wall bracing. If we have a narrow wall, like one commonly seen next to a garage door opening, as wall bracing, when a lateral load is applied at the top of the wall will want to tip over like a tall, skinny filing cabinet. By adding more panels, you can reduce or eliminate the chances of the wall tipping over or overturning. In locations where there isn't enough space to add more panels, another approach must be used. Portal frames are one solution to this problem. Narrow walls without special detailing adjacent to large openings simply can't provide the needed shear capacity to resist the forces that are imposed on the sidewall of the house. Properly constructed portal frames allow for much narrower sidewalls, thereby increasing the resiliency of houses. Without sufficient bracing, a wall can rack over or collapse when subject to lateral loads. Racking occurs when a rectangular wall changes to a parallelogram shape, where the top and the bottom of the wall are parallel, but the sides are no longer vertical, as seen in this photo. The damage shown in this picture is consistent with wind damage from an EF2 tornado. The failure in this structure likely could have been minimized with a properly constructed portal frame. As you can see on the right side of the garage, the sheathing joint occurs at the wall-to-wall header framing joint. Locating the OSB or plywood joint at this location in a portal frame significantly reduces its capacity. In this photo, you'll notice that the structure wasn't fully sheathed when it was exposed to an earthquake, but it's another great example of what racking looks like. APA has a long history of investigating structural failures after natural disasters. Because high wind events or earthquakes are rare, it can be difficult to grasp their possible damaging effects on a structure. Ensuring that homes can withstand lateral loads is critical to the safety of the building and its occupants in the event of high winds or an earthquake. That's why APA developed a wall bracing method that incorporates a portal frame. Originally developed and tested at the APA laboratory in conjunction with the Master Builders Association of King County, Washington, it was later refined and added to the IRC as a prescriptive narrow wall bracing unit for use next to openings. Site-built portal frames are an easy way to provide lateral resistance with a narrow panel. Next, we will take a look at some of the basic installation requirements for a typical portal frame. Understanding critical elements of construction is important, particularly when it comes to portal frames. No matter what method you use or how many portal frames you need, it's important to understand proper installation. Let's review some basics about proper portal frame installation. The wood portal frame hasn't changed much from the original APA design. The header extends past the opening and a semi-rigid moment connection is made by overlapping plywood or OSB sheathing over the header. The sheathing is attached to the wall studs and to the header with closely spaced fasteners, and the sill plate is bolted to the foundation. All portal frame methods have some common aspects that builders and framers need to be aware of. The first is that the minimum garage door header size is 3 inches by 11 1/4 inches, which can be achieved by installing double 2x12 or a single engineered wood product. However, the header size may need to be greater than that. A steel header is prohibited. Furthermore, the header needs to be extended over the narrow wall and should be nailed to a king stud at both ends of the opening. The wall sheathing is fastened to the header with 8-penny common or galvanized box nails in a 3-inch grid pattern. To fasten the highlighted trimming member to the header, 2 rows of 16-penny sinker nails at 3 inches on center is required. It's also important to extend the sheathing continuously across the header and the pony wall if there is one, and any joints must be as close to the midspan of the opening height as possible. The best location for a sheathing joint is within 24 inches in either direction of the middle of the opening height. If a sheathing joint is needed, slice panel edges into common blocking with 1 row of 8-penny common nails at 3 inches on center in each panel edge. Depending on the portal frame method used, either anchors, hold downs, or a combination of both are required at the base of the wall. This is to ensure proper load continuity from the framing to the foundation or from floor to floor. Some additional common characteristics of portal frames are all portal frames have a maximum 10-foot header height measured from the top of the foundation to the top of the header and are limited to a 12-foot maximum total wall height measured from the top of the foundation to the top of the top wall plate. Pony walls up to 4 feet high can be built above the header. And all portal frames require tension straps on both sides of the opening on the interior side of the wall, fastened to the jack stud closest to the opening and extending up over the header and the pony wall if there is one. Straps should be installed in accordance with manufacturer's instructions. In the next section, I'll explain the requirements and restrictions for the portal frame methods found in the IRC. We've looked at load paths and the importance of portal frames. Next, I'm going to explain where portal frames are typically used in a house design and then discuss each of the 3 portal frame methods in more detail. Designers use portal frames per the IRC wall bracing provisions when traditional full panel wall bracing solutions don't work, such as narrow walls next to openings. In this house design, where there are several openings, a portal frame may be added on the corner of the garage to comply with code. As per the 2018 IRC, section R602.10, for a house designed to either the intermittent or continuous method of bracing, a qualifying braced wall panel must start no further than 10 feet from the corner of the house. A portal frame provides bracing capability where otherwise you would need a wider wall or an engineered solution. The most common approach is to put a portal frame on each side of the door. A portal frame on both sides of the garage door opening will increase the wall's lateral load capacity, allowing for more openings throughout the rest of the house. This 2-car garage is shown with 2 single portal frames. It could also have a portal frame in the center between the 2 openings. Either way, the header should not be continuous over the 2 garage door openings. According to the APA ICC Wood Wall Bracing Provisions Guide, a continuous header across both openings is not permitted. If a portal frame is added to the space between the 2 openings, the header over the left opening would span the opening to create a double portal frame. The header over the right opening would bear on the left side on a separate jack stud with a king stud next to it to create a single portal frame. This is how a double opening should be fabricated. This method can also be used for a 3-car garage that has a combination double-car garage door and a single-car garage door. The IRC has 3 different types of portal frames that can be used. First, we're going to look at Method PFH, which stands for Portal Frame with Hold Downs. Portal frame with hold downs can be used for intermittent or continuously sheathed brace wall lines and can be used on a single-story structure or on the bottom of a 2-story structure. A 12-inch by 12-inch footing must be installed under each wall that uses this portal frame. This method requires 1 5/8-inch diameter anchor bolt with a 2-inch by 2-inch by 3/16-inch thick plate washer, as well as 2 3,500-pound strap-type hold downs embedded into concrete and nailed into the framing. This method is the only portal frame method that utilizes hold downs. A minimum 3/8 performance category sheathing can be used for this method, and the wall can be as narrow as 16 inches for a 1-story structure, but must be 24 inches if the portal frame supports a story above. In either case, Method PFH provides 48 inches of contributing length of braced wall panel. The next method we're going to look at is Method PFG, which stands for Portal Frame at Garage Door Opening. This method is a light version of Method PFH. Method PFG can be used in low seismic areas only and is only allowed next to garage door openings. It can be used on a single-story structure or on the bottom of a two-story structure. The wall must be at least 24 inches wide for an 8-foot header height. Taller header heights require wider walls. This method provides a braced wall panel length of 1.5 times the width of the portal frame. So for a 24-inch wide portal frame, you would get 36 inches of braced wall panel. This method requires 7/16 performance category wood structural panels and 2 half-inch anchor bolts with plate washers. No hold downs are required. Note that for a single portal frame for Method PFG, there is a requirement for the wall on the other side of the garage door opening to qualify as a braced wall panel as well. If Method PFG is used on both sides of the garage door opening, this requirement would be met. The third method, Method CSPF, which stands for Continuously Sheathed Portal Frame, makes use of the extended header that we discussed earlier, but without hold downs and with continuous sheathing on the rest of the wall line. This method allows for panels as narrow as 16 inches for an 8-foot header height. Taller header heights require wider walls. Like Method PFG, this method contributes 1.5 times the actual length to the length of braced wall panel. Like Method PFH, this method can also be used in high seismic areas, but only contributes its actual length in those locations. This is the only portal frame method that limits the number of times it can be used. You are limited to 4 CSPF panels in any single braced wall line. This is also the only portal frame method that can also be used on the upper floor of a structure. On the ground floor, the IRC requires 2 half-inch anchor bolts with plate washers, as shown in the detail on this slide. No hold downs are required. To install this method on an upper floor, the IRC provides 2 options. One utilizes framing anchors to create a load path from the portal frame to the band or rim joist. The framing anchors must have a capacity of 670 pounds. The second option utilizes the wood structural panel of the portal frame to create this path. The panel is extended down over the band or rim joist and attached with 8-penny nails. Aside from the use of hold downs versus anchor bolts and some of the other differences we have discussed, the 3 different types of portal frames also vary when it comes to framing and nailing requirements. The details in the IRC do show these differences, so I'm just going to summarize them here to make sure you're aware of them because they can be easy to miss. All 3 types of portal frames have a king stud and a jack stud on the outside of the frame, and 2 jack studs on the inside of the frame adjacent to the opening, as well as a double top plate at the top of the narrow wall. At the bottom of the wall, the portal frame at garage and the continuously sheathed portal frame have a single bottom plate, while the portal frame with hold downs has a double bottom plate. Both the continuously sheathed portal frame and the portal frame with hold downs have a 3-inch fastener pattern in all of the framing within the narrow wall. The portal frame at garage has the 3-inch fastener pattern only as shown in the image. The red arrows indicate the framing members that do not require fasteners. I mentioned earlier that all the portal frame methods in the IRC require tension straps next to the opening on the side of the wall opposite the sheathing. But what is the purpose of these straps? When the wind blows on a home, it creates a pressure and suction force on the windward and leeward walls. These are the walls perpendicular to the direction of the wind. On a typical wall, the studs span from floor to floor or floor to roof, so they can transfer the pressure or suction load to the floor or roof sheathing. But with a portal frame, the studs are not continuous from floor to roof because the header must extend over the narrow wall. Without this continuity, the wall's ability to resist the wind force is weakened, and the wall can fail at the joint between the header and the top of the narrow wall below. We call this a hinged joint because it is not rigid and cannot transfer a significant amount of wind load. The purpose of the tension strap is to provide rigidity between the narrow wall and the header and prevent the joint from hinging or bending inward or outward when the wind blows perpendicular to the wall that contains the portal frame. It is a critical element of a properly functioning portal frame. Proper tension strap size for portal frames is provided in Table R602.10.6.4 of the IRC. All portal frames also require a 3-inch by 3-inch fastener pattern at the intersection between the header and the narrow wall. This fastener pattern is a big part of where the portal frame gets its strength to resist lateral loads. When a lateral load is applied to the top of the portal frame, it must be able to transfer that load through the narrow wall and down to the foundation. But as we saw earlier, a narrow wall will fail by racking if there isn't sufficient strength. By extending the header over the narrow wall and creating a semi-rigid connection by fastening the sheathing to both the narrow wall and the header with a tight fastener pattern, the assembly becomes a semi-rigid frame that prevents the structure from racking while the exterior sheathing transfers the load down to the foundation. Only one of the portal frame methods in the IRC, Method PFG, requires hold downs. But why does this method require them when the other two don't? I explained earlier how a narrow braced wall is like a tall, skinny filing cabinet that wants to tip over when a large enough load is applied at the top. Hold downs prevent this tipping from occurring and so allow the portal frame to carry a larger load than without hold downs. Method PFG provides 48 inches of braced wall panel, regardless of the width of the portal frame. The other two methods provide less than this, especially at the narrower widths. So hold downs can maximize the capacity of a portal frame. This may allow for more openings, such as windows in a wall line. On the other hand, builders often want to minimize the amount of hold downs used in a house. If so, Method PFG may not be the best option, and another option, such as Method CSPF, may be more appropriate. Each of the different portal frame methods provides different options and advantages. These should all be considered when selecting a method to use. Portal frames are a tested assembly. To achieve the tested capacity of the portal frame, they need to be built as they were tested. If they are not, they will not meet the prescribed design and will not perform to the required capacity. In this last set of slides, we will look at some portal frame installation errors that are commonly observed by APA. Let's start at the top. What do you see wrong with this picture? Is the tension strap located in the correct location? Proper location is along the jack stud closest to the opening. Tension straps vary in length and size, and the appropriate capacity strap should be referenced from the IRC. The stud at this location should align with the correct location of the tension strap. This portal frame is also missing the framing members attached to the top and bottom of the header. Missing framing is a common installation error with portal frames. And the final error is the stud on the left side. This should be a king stud and run continuous past the header up to the top plate. In this picture, the sheathing joint is located at the wall to header framing joint. By locating the OSB or plywood joint at this location, the capacity of the portal frame is significantly reduced. It's important to extend the sheathing continuously across the header and the pony wall if there is one, and any joints must be as close to the midspan of the opening height as possible. The best location to locate a sheathing joint is within 24 inches in either direction of the middle of the opening height. Portal frames also require a tighter fastener pattern than other bracing methods in the IRC. A tighter fastener pattern is critical for keeping the portal frame semi-rigid to prevent racking. A portal frame requires OSB or plywood to be fastened with 8 penny common nails into the required framing members at 3 inches on center and a 3-inch by 3-inch grid of fasteners at the intersection between the header and the narrow wall. Anything less will reduce the capacity of the tested portal frame assembly. There are 2 common errors we see with the 3-inch by 3-inch grid fastener pattern. The first is the location of the fasteners. In this picture, there is no 3-inch by 3-inch grid of fasteners at the intersection of the header with the narrow wall. There are numerous fasteners along the header over the garage door opening. This is incorrect. The grid pattern must occur at the overlap of the narrow wall sheathing and the header. Locating these fasteners correctly is absolutely critical to creating a semi-rigid frame to resist lateral loads. With the fasteners in the location shown in this picture, this will not be accomplished. The second common error we see with the 3-inch by 3-inch grid fastener pattern is the spacing of the fasteners. You can see in this picture that the spacing of the fasteners are not consistent and do not meet the requirements of the IRC portal frame details. The 3-inch by 3-inch spacing is important, and larger or smaller spacings may affect the strength of the portal frame. Now let's move down to the bottom of the portal frame, where we have a few more common errors. Notice where the sheathing joint is located in this picture. It's just a few inches above the bottom plate. This is a common mistake that not only weakens the portal frame assembly, but if done this way around the perimeter of the structure, it will weaken the load path continuity of the entire structure. Where hold downs and anchors are located is also important. As we discussed, portal frames need 2 anchor bolts or 2 hold downs and 1 anchor bolt, depending on the method. The hold downs or anchor bolts resist overturning and should be as close to the corners of the wall panel as practical to ensure that both ends of the narrow wall are attached to the foundation below. Going back to the example of the tall, skinny filing cabinet, both sides of the cabinet need to be anchored down to prevent tipping in either direction. Placing both hold downs or anchor bolts to one side of the portal frame, as shown in the pictures, will not perform as tested. The detail shown in the IRC for method PFH, portal frame with hold downs, specifically requires a strap type hold down embedded in the concrete foundation. Hold downs used for this method must match code requirements. In this picture, the hold down does not match the IRC detail for method PFH. APA has published a 2-sided builder tip that is written in Spanish and English. The document provides framing tips when fabricating portal frames. The builder tip, as well as several others, can be downloaded for free from apawood.org. For more information on the design aspect of portal frames, you can refer to the IRC Wood Wall Bracing Provisions Guide, developed by APA and ICC, and available on the ICC website for all recent code cycles. Your local APA engineered wood specialist, located in the regions shown on the map, is also a free resource that is available to you for wall bracing assistance or any other questions you may have regarding wood products or construction. Their contact information can be found on the staff contacts page of the APA website. You can also visit apawood.org. There you'll find hundreds of resources relating to engineered wood products, including the APA wall bracing calculator, which is available for free on the APA website and is a quick and easy way to ensure your project meets IRC wall bracing requirements.
Thank you, Kathy. Some questions came in while you're speaking. We'll answer a few of those now. Let's see. First, I see some builders use wood structural panels instead of metal strapping on the back side of the portal frame. Is this okay?
Unfortunately, wood structural panel doesn't have the tensile capacity to be used in place of the metal strapping. There is the option of using a 2x4 or a 2x6 piece of lumber, which could be substituted. You would just need to make sure that it has the tensile capacity required, and then make sure that it's attached or nailed properly to meet the strap capacity that's required by the code.
Okay, great. Second, what is the purpose of the 5/8" anchor bolt at the base of the PFH, the portal frame with hold downs, if it has hold down straps?
The reason why method PFH requires an anchor bolt is because the hold down straps are there primarily to provide the resistance to the overturning, like we talked about with the tall, skinny filing cabinet. So the hold down straps are actually providing resistance to the overturning, but they do also provide some resistance to shear. So only one 5/8" diameter anchor bolt is needed to provide the remaining resistance to the shear load.
Thank you. You mentioned that double 2x12 can be used for the portal frame header. What are the requirements for how the two members should be fastened to each other?
So the information for attaching a built-up header is just the same as what's provided in IRC table R602.3 parenthesis 1. That's the big attachment table in section 602. That table also applies to a built-up header that's part of a portal frame.
Okay, and we have time for, I think, of one more. While doing inspection of houses, I always find a lot of errors with portal frames, but get a lot of pushback if I try to have them all corrected. What are the most important areas that I should focus on?
Unfortunately, there isn't really a list of the most important parts of a portal frame. As we mentioned earlier, it's tested as a complete assembly, and all the detailing that is shown is all very important to making sure that the portal frame performs as tested. One option when you run into this situation would be to provide a copy of our builder tip F435 that I mentioned a few slides ago, and that explains the proper construction of portal frames. You could provide that to the crew. As I mentioned earlier, that's a free download from our website.
Thank you, Kathy. I should mention that if you have technical questions on any topic related to the use of engineered wood products, please don't hesitate to contact the APA Help Desk at the address shown here. Before we conclude, I'd like to touch on a couple of things related to a short survey and upcoming webinars. We'd really appreciate receiving your feedback via the survey that you'll receive shortly, so please take a minute and fill that out. And make sure that you're signed up to receive our APA Update newsletter so that you'll be notified of future webinars and updates to APA publications and standards. To receive it, all you need to do, starting from the home page of our website, is to click on Sign in the upper right-hand corner of the page. In the menu that drops down, simply select Register. From there, you'll need to let us know what you'd specifically like to receive, which in this case is the APA Update newsletter. As mentioned earlier, a recording of today's webinar and answers to the questions that were asked will be posted at apawood.org in a week or two. And with that, I'd like to thank you for attending. Have a great day.